There's just the guts of a cheap, nasty LED nightlight that failed recently. Quite simple circuit, just a pair of PCB mount receptacle blades, or no, plug blades. There, half watt, 18,000 ohm carbon film resistor. Bog standard 5% stuff. Guess it has gotten a little bit toasty over the years. As you can see, its PCB material's going brown, but this crappy paper stuff likes to do that. Well, that can be a problem as far as tracking issues. 1N4004 bog standard 1 ampere 400 volt silicon rectifier diode, and a blue super bright LED. And of course the LED has, as far as I can tell, failed short in all the testing, which pretty much has failed short. I suspect that's because due to the reverse current through the diode, which is going to be on the order of some tens to hundreds of microamperes over the years, that causes the LED to fail, because I have heard of reverse current induced or reverse bias induced failure in indium gallium nitride dye chemistry LEDs, which this, being a modern blue LED, is. That's really the predominant. That's really pretty much the only super bright dye chemistry for everything from, I think, UV or near UV LEDs all the way to yellow and yellow-green. Of course, blue being right in the middle of that. And of course, another little nasty thing about it is one leg of the mains feed for it. PCB trace, LED. Other leg of the mains feed. And because of the LED presenting either anywhere from about 3 volts to 5 volts drop, regardless of the, or depending on the potential across it, there's going to be up to about 167 volts across that gap. Considering that our mains feed is about 122 volts, slightly above normal, 122 volts, 123 volts, but still well within spec. It's more like about 170 volts across the dinky tiny gap, which is about maybe 50 mils. Yeah, not good. Cracking issue, but then again, Chinese crap. Don't have the diffuser for it, but it was a kind of a, injection molded polycarbonate kind of a flame thing. Same basic idea as this one on this other nightlight. And this is the board out of that one. It's a lot more complicated. It's basically it's a capacitive dropper instead of a resistive one. The only real advantage of the resistive one is that it basically doesn't give a toss about the waveform as far as limiting current, and all it cares about is the RMS potential on the half of the cycle where it's conducting. This one, of course, running it on either a square wave, a modified square wave, or a pure sine inverter that doesn't have adequate mains filtering, which is the norm for a lot of the cheaper ones on the market. All your harmonic content, because the capacitive reactance is inversely proportional to frequency for the third harmonic, 180 cycles per second here in 120 volt mains land. The capacitor is only going to have reactance 1/3 of normal, 5th harmonic, 1/5 normal, etc., etc. And given the very high harmonic content that is present on those, especially the square wave and modified square wave inverters, it means greatly excess LED current, premature failure. Also, it isn't good for the cap and all the various other ancillary stuff. Although at least this does have stuff like a Zener / avalanche diode there as part of the regulation circuitry. I did draw this out at one point. By the way, opening these things up, risk of electrocution, blah de blah. Don't plug them in as is. You could die. Mains potential across those two terminals. Don't do it, you fools. Blah de blah. Stupid people piss me off. But yeah, at least this has some kind of circuitry to prevent that. And of course, with this, it could be very easily alleviated by having a just a little single chip Grayet's bridge in there. And also it could be improved by having more LEDs in series, because then you could reduce the current substantially. Of course, it would drive up the BOM cost, but considering that the Chinese are stamping these LEDs out by the billions, especially given how the blue dyes are manufactured in such huge numbers for these things, because they're also used in white LEDs, they're actually some of the cheapest, even with them needing, very exotic, sapphire wafers and whatnot, even though I think Plessy has, they've come up with some blue LED or blue junction on silicon things. I know Mike's Electric Stuff was mentioning something about, or Mike Harrison of Mike's Electric Stuff, by the way, if you don't watch his stuff, you should, was featuring some stuff in a fairly recent Amp Hour podcast. But again, that's just, random rambling just because I've done a video on Bloody Ages, and don't expect anything more until May, at least, because busy with loads of crap. Because engineering student, although I hope to have some more stuff, starting sometime this summer, as far as, clearing a lab space and being able to resume working on my maximum PowerPoint charge controller project, as well as hopefully being able to get a really good power analysis oscilloscope, just because I'm not necessarily crashing into the limits of my Rigol DS4014, but the limits are in sight. Although, needless to say, I'm not going to be getting rid of that scope, because due to, crappily implemented in a good way, gain roll-off in the front end, combined with a very high sampling rate for its bandwidth, it's useful up to well into the hundreds of megacycles for qualitative measurements, if nothing else. So yeah,